So here we're asked to find the derivative of a function using the chain rule explicitly. So this here is the function that we're working with, and remember, for a chain rule, what you're looking for is an inner function and an outer function. So if I have a look at this one here, my inner function is essentially going to be what sits inside the brackets, okay? Because it's this kind of inner function that's all being cubed, all right? So I'm going to do it the long way. What we start off with is we let u be our inner function. So in this case, it's 2x to the 4 plus 5. And then we want to take the derivative of this inner function with respect to x. So that's du on dx. So we can apply our power rule here. So we get 4 times 2, which is 8, x, and take 1 off the power, which goes to 3. And then, of course, the derivative of 5, it's just a constant, so it goes to 0. So now what I want to do is go back and write out my equation for y, but in terms of u, what I've let my inner function be. So now I can write this as 6u to the power of 3, okay, because u was equal to what was inside the bracket. So if I take the derivative of this with respect to u, my inner function, again, it's just the power rule, so we get 3 times 6, which is 18. Write out our variable and take 1 off the power, so power of 2. All right, so now we're at the point where we can apply our chain rule, and that's, of course, that we want dy dx, okay, the derivative of our function with respect to x. And we can get that by multiplying together these two other derivatives that we've found. Okay, and what we can see is that we've got a du on the top line and a du on the bottom line, which essentially implicitly cancel each other out, and we're just left with dy dx. Okay, so if we go ahead and actually substitute into this, we're going to get 8x to the power of 3 multiplied by this one here, which is 18u to the 2. So I can make this nicer by figuring out 8 times 18, and this in a calculator comes to 144. I've got my x cubed, and then I have u to the power of 2. And rather than answering in terms of this variable we introduced, we can go back and say, okay, u here was actually equal to this expression in x. So we can just replace it. So 2x to the 4 plus 5, and that's all squared. So that there becomes our answer for the derivative of our original function. Now I just want to show you a bit of the shortcut way where you should get the same answer, but you just don't write out all of the kind of intermediate steps. So we'll start again with our function, which is this here. And I'm going to jump straight away to finding the derivative. So I'll call it dy dx. So our starting point is to take the derivative of our outer function with respect to our inner. Okay, so we're just considering this as 6 something to the power of 3, and we want to take the derivative with respect to the something, okay, because that's our inner. So we go top number times front number, which is 18. We write out whatever that something is, 2x to the 4 plus 5. We take 1 off the power. And now we want to multiply by the derivative of our something, our inner function, with respect to x. So just considering that what's inside the bracket, our inner part, we know the derivative is 8x to the power of 3. This goes to 0. Okay, so now we're kind of at the point where we can just make it nicer again. So 18 times 8, we said before, was 144. We get our 2x to the 4 plus 5 all squared, and the x cubed as well. And if we look down here, it's exactly the same, except that I've got these in the opposite order, but that's just a formatting thing. It's exactly the same equation. So that's all there is in terms of this video.